This is Euclid Book 10, proposition number 32. Here's the diagram. Okay. Let's get into this. This down here. Alright. It says to find two medial straight lines commensurable in square only, containing a medial rectangle, and such that the square on the greater is greater than the square on the less, by a square on a straight line commensurable with the greater. Okay. Here we go. Let there be set out three rational straight lines, A, B, and C. And these are commensurable in square only. That means, like we've said so many times before, no number will measure all three of these lines, but if you squared all of them, there is a square area that will measure all three of these square areas. Okay. Let's go on. And such that the square on A is greater than the square on C by a square on a straight line commensurable with A. And that's by Euclid Book 10, proposition number 29. Okay. So what that means is if you square this and you square this, this is bigger than this, and how much bigger it is by a line, and I don't know which one it would be, but by a line that is commensurable with A. Okay? And let the square on D be equal to the rectangle on A and B. Okay, so you're going to take A and B right here, you're going to make a rectangle out of them, and you're going to make a square on this. Okay? And so the area in that square is going to be equal to the area in that rectangle. That's what they're saying. Therefore, the square on D is medial. Therefore, D is also medial. And that's by Euclid Book 10, proposition number 21. So if the square on D is medial, so is the actual line itself. That's a medial line. Okay. Let the rectangle DE be equal to the rectangle BC. So, we're going to take these two lines and make a rectangle out of them. We're going to take these two lines and we're going to make a rectangle out of them. And the area in this rectangle is going to be the same as the rectangle at the... Boy, let's try that again. The area in this rectangle will be the same area as the area in this rectangle. That's what I'm saying. Okay, let's go on. Then, since as the rectangle AB is to the rectangle BC, so is A to C. Okay. So as the area of this rectangle is to the area of this rectangle, so is A to C. So is line A to line C. Okay, now we got that. While the square on D is equal to the rectangle AB. Well, we already established that the area in this square is equal to the rectangle of these two lines. Okay. And the rectangle DE is equal to the rectangle BC, which we've already established. Therefore, as A is to C, so is the square on D to the rectangle DE. Okay. So now what we're going to say is, as A is to C, as this line is to this line, so is the square on this line equal to the rectangle formed by these two lines. That's what that's saying. But as the square on D is the rectangle D and E, so is D to E. Okay. So as this square is to this rectangle, also as D is to E. So as this line is to this line. Okay, let's go back one more time. As the square on this is equal to this rectangle, well, not equal, sorry. This is a proportion here. We're going to be drawing a proportion. I know you're getting confused now. Yep. Alright, let's try that again. As this square is to this rectangle, so is this line is to this line. That's what they were saying. Well, that's what Euclid was saying. Let's go on. So now we can say, as A is to C, so as D is to E. What does that mean? That means as this line is to this line, so as this line is to this line. That's what it means. Okay. But A is commensurable with C in square only. That means that these two lines are not commensurable. But if you square this and you square this, they are. Therefore, D is also commensurable with E in square only. That means that no number will measure both this line and this line, but if you square this and you square this, there is an area that will divide both those areas. Okay. Now, we've talked about this so many times in Euclid Book 10. And of course, all this is possible by Euclid Book 10, proposition number 11. But D is medial, so E is also medial. And this is by Euclid Book 10, proposition 23, addition. Okay? So if this line is medial, so is that. And since as A is to C, so as D is to E, while the square on A is greater than the square on C by the square on a straight line commensurable with A, which we talked about early in the proof, therefore also the square on D will be greater than the square on E by a square on a straight line commensurable with D. And this is by Euclid Book 10, proposition number 14. So the square on this is greater than the square on this by some area in which one of the sides is commensurable with D. Okay. I say next that the rectangle DE is medial. For since the rectangle BC is equal to the rectangle DE, while the rectangle BC is medial, and this is by Euclid Book 10, proposition number 21, so now we are saying that this rectangle is medial. And because of that, and because that the rectangle here has the same area as the rectangle in here, if that rectangle is medial, so is that. Therefore, two medial straight lines, D and E, commensurable in square only and containing a medial rectangle, have been found such that the square on the greater is greater than the square on the less by a square on a straight line commensurable with the greater. Okay, so we've actually proved what we came out to prove. Similarly, again, it can be proved that the square on D is greater than the square on E by a square on a straight line incommensurable with D, when the square on A is greater than the square on C by a square on a straight line incommensurable with A. This is by Euclid Book 10, proposition number 30. And that is the whole proof. I will tell you more in a future video. Stay tuned.